Ollie's arm. This is made up of the main arm piece, which is a single print. I printed that in flat on the bed here, which is tricky because then you need to print with supports, but they came out pretty good after it was all painted up and filled in. It just means that printing down that way, there's no internal supports needed for where we need all the clearance of these holes, and we get better precision on the heat inserts and where the magnets go and stuff like that. So if we go through, there's a couple of other printed parts. There's a housing to hold the servo. One of those is a clamp to hold the rear servo in. There is a hub, which is where the arm insert goes into the body, and then that attaches to the main arm pivot out of the body. These are doweled together. There's a cavity in here for cables. This section here of this gear is printed, but this can also be cut out of and made from an acetal gear of the same teeth amount. So you could buy one acetal gear of this size, a blank disc. I think the hole spacings maybe match, maybe not, but just that if this gear is wearing out, we could make that out of acetal. So I've sort of thought ahead to replace that, but tried to do it as a 3D printed part as well. There's some 3D printed dowels, some 3D printed spacers. I'll explain why I've done the spacers. You could use washers instead if they end up being the same thickness. And some caps that go in the ends of the arm. The arm covers, which just go on with magnets. Pretty nice. They're just glued in. These are diameter 8 by 3mm thick neodymium magnets. I labelled it so I don't get it wrong. And the servos, there's a servo attachment here which is glued in to a servo horn, a round one, and I've got a couple of screws just for positive contact. These are the MG996R, both of them. So two of those. The servo gear, this is a spur gear, brass spur gear, and it's a 32.8 module with a servo attachment to suit the servo horn. So it has a 25 tooth servo horn attachment. I can put the description online when I do the video edit. So of course everything will be doubled because you've got the other arm. Make sure you don't print two of the same arm because they are opposite. The other part we have is an M8 socket head cap screw or something similar that's going to fit into this space, which is 55mm long. Socket head cap screw, M8, and a nut. And that's about all the parts. So these end caps I've just got tape on at the moment when I painted it. I'm just going to put a drop of hot glue there and just retain those, so if I need to maintain it I can pop them out. Mine are a bit of a tight fit, but so if we talk about the arm, there's also the other hardware. There's the 608 ZZ diameter 22 by 8mm bore, 7mm wide bearings. There's 1, 2, 3 inside there, and 4 of those to install. The ones that are in the back here, I would suggest put them in, trying to find another one, put them in on the inside and then use a clamp on the inside to squeeze them in they've got to be inserted from the inside out because they have a housing that pushes in there. If it's a loose fit you could just press them in there or push them in, and same with the front here. Put a piece of timber across the front so you're not squeezing against the thin part of the plastic, and then just clamp that in. And the other option is always just use a draw bolt, so put both bearings in, a nut, and then squeeze that all together to squash the bearings in. These are for the main arm. When the hands are done, the hand will go in and that'll be the pivot. So the other thing we need is, again, the M3 by 6mm long heat inserts. So I think I've gone through about 300 of these on the build. There's 3 in here, 4 in here, but I think there's one of these I can't actually get to, but we'll see that when I do it. So once you have the magnets installed, the bearings pressed in, again, check things aren't tight, there's no fitment issues, stuff like that. Now, I'll talk about this lever. So remember when Wally, his arm is pivoting, there's a lot of force that's happening on that pivot point. I have an arm mechanism which is spring loaded to balance this as an equilibrium, so I can get away with a less heavy duty servo on the end of this when it pivots the whole weight of the arm. But my whole arm mechanism ended up weighing about 1.4 kilograms, and then you can work back from there and figure out how much torque you actually need on the servo to rotate the arm at a distance of 250 millimeters, I think it was, for 1.4 kilos. So what I have here is more of the diameter 8. Really it's just precision bar or ground bar. These, I'm trying to remember what the length of this was, but I'll find that on the model and put it on the screen. Pretty certain this is 150 millimeters long, this shaft. It inserts into the 3D print, into here. This is where the cable management goes. The cables go through there and they come out the slot in the bottom. And maybe I can grab a cable and put it in the hole for you. I don't know if the servo, I know they'll have to take that horn off and then push that through. I plan on having only 4 wires go through here. I plan on having a PCA 9685 servo breakout board in the arm itself, so that the 4 wires can come through. I won't have a connector here. The connector will be out inside the body. So when the 4 wires come through, sorry, by the way, when the 4 wires are coming through that cavity, I can end up having 5-volt ground, 2 signal wires, and then from the arm I have 1, 2 servos, and then in the hands on my design I have 3 servos. So there's 5 servos I have to manage. So I don't want to have to run 5 cables through here. I'll just send it all through a I2C, through a wire communication, and that'll just plug the servos into here easy enough. That's the plan. This shaft I pushed into that part. I then drilled through the shaft while it was fitted into here, just carefully, and then for an M4 socketed cap screw bolt, which I had a nylock on the back, and then I've just ground that flush and filed that flush with the top of the print so that it doesn't clash on the inside of the arm here when it pivots. So the reason I've done that is, and again this part I've printed quite solid, about 5 or 6 walls, because there's so much force on that arm when Wally's trying to turn. This cap has 2 dowels in it, line it up with there. I'll just put a bit of glue on here to retain that. This is really just a cosmetic part, it doesn't do anything. So there's no strength, but it was just to give orientation for the cable management to go through. The shaft I then filed on a flat, 75 millimeters long. So I kept the flat in line, parallel with this edge, so that when it all goes together, then the arm will be orientated in the right spot once we fit that together. This is to suit the arm mechanisms, which I grab on is this. This will mount against the inside face in the robot, in Wally's body. This will push through. There's flats, a D slot on the arm component, so this will come through. It'll line up into where the slot, same D is on there. That'll keep going in. Snug fit. And then that'll be the part that with mine it has a spring tensioner which tries to keep the arm in a static weight position. But I'll go into this mechanism a bit later. But again, just so you know, this flat ended up being, so again, diameter 8 shaft, and the flat from one edge to the flat needed to be 7 millimeters. You could have it a little bit less, but the better a fitment you have it, the more strength you have in your design or in your assembly. So again, shaft inserted, cap on. Again, you can drop a bit of glue on there. M4 drilled hole through the shaft, flat onto the shaft. Tooth geared insert screwed in. There's heat inserts underneath this. I just don't want to have to take mine out now it's all assembled. You could put a drop of glue on that, but again, I've got to see whether that wears over time onto this tooth geared here, and if it does, I'll replace that. So once the bearings are in, heat inserts, I'd suggest this servo bracket, you'd have to zero the servo horns as well when you put these things in before you assemble it. So zero, put the horn on. This one inserts, there's a clearance spot just at the bottom here, and that's where this one goes. So on the other arm, this would be an inverted component to that. There's heat inserts into here. It's a bit thin here, but everything's getting a bit tight on the clearance. So this will insert. So. Okay, the other bracket. Again, you need to zero out the servo horn, and this servo horn, once it's on, should be pointing vertical to where that hole is at the front. So once you zero it, then have that in the right position. This has got heat insert here and here. I think I've got space for the other two, I just haven't put them in for some reason. And that's the one I can't get in, so you probably don't need to omit that hole, because I just can't get past the edge of the servo itself. Again, this is just check the fitment on these. It's a bit of a weird orientation, but it's just so that the servo would actually fit within the space of the arm. Otherwise, if I did it that way, it would stick out the edge of the arm, which wouldn't be any good. So I just rotated it up a little bit, a weird angle. This should then just drop in. There's the other cable. So that's both the main servos in. Again, I've just got to check fitment and everything and sort of see where I can actually fit my breakout board with cable management, but I'll do that later. It depends on your drive system, control system, how you want to do it. Remember that the other servos from the fingers will be coming in through, there's a slot in the front here, and the reason the slot is a 180-degree slot is because the hand will rotate, or the wrist will rotate around 180 degrees. So it gives flex for that cable to come around. This screw, the M3 in here, which goes in for where the hand inserts, that could be a grub screw to make sure you've got clearance there, so I'll probably swap that over for a grub screw. So the rest of the arm, a little bit tricky on the end here. So you can see the geared tooth will line up with this. But I made these washers, printed washers, just so that these are adjustable to give this a good fitment. It's a little bit tricky, but kind of get them in and then try to line everything up. which way is up, and that's where the gear will mesh. And there are bump stops on this mechanism, so that will come in and mechanically restrict the range of motion, so you get 30 degrees motion of the arm going out, and then that will stop at about, I think it's nearly 5 degrees inwards motion. So hopefully that'll restrict from smacking into Wally's body with the arm itself. So the edge of the body will be there. Let's have a look at that. Yeah. And then 30 degrees outward motion, which is quite a bit. It's a big hand. I'm trying to remember which way is up on this one. I think the flat was up, so that's in the right way. I'll just get this nut started on here. Again, I'll probably put a small amount of Loctite on here just to retain it, a thread retaining compound. But I'm just holding that with a screwdriver, something on the other side, just while I do that up to get it to bite, and then just a firm, till it's firm. The washers, the other part of the washer is intended that it's clamping on the inner race of the bearing, so you don't end up with that seizing on the mechanism. Caps go on, like I said, I've just got a bit of tape on there for now. 1, 2 caps. And you'd put the hand in, I'll grab it for now just to show you. Okay, we'll grab Wally's hand while we're at it. Here's the hand, here's the shaft, and the groove or the hole where the cables will come through. This is the part, I've put a small flat here where I filed that. You could grind this a bit further, it doesn't matter about how long it is. Again, it's just the flat is then to key in with that screw. So when this comes in, that shaft needs to line up, or that flat, with where that screw hole is. And that'll just push into there, and then we can do the screw up on the arm. Just till it's firm, and that's how the servo will rotate the hand. Most servos you'll get, they say 180 degrees, but you probably have to program it in to get the actual 180 degrees out of it. Depends on the servo you have. And that's about it. The reason there's a hole there, it was to line up with this grub screw in case I had to adjust the rotation or something of the hand to give fine adjustment. So that just bites into the shaft, so I could undo that if this was here and the wrist was out of position a little bit. I can then actually change that by undoing this one and then rotating that back and then doing that up again. And then the cover goes on. So in all you're going to need 6, 12, 24 of those diameter 8 by 3mm magnets, and then it clips on. Quick discussion on the paint. I used the Rust-Oleum Caterpillar Yellow as the base. I then went in with a really dark grey, a charcoal grey, and sort of weathered the edges. Kyle McMaster's got a great video online for how to do that. I then went over with a rough sponge and did, on the arm itself, I only really went over with an orange. I did put yellow sand actually with PVA glue underneath the yellow coat, so after I'd primed everything, it smoothed out all the print. And then I went in here with like a dark brown and then the orange on top. The arms I masked with masking tape, and instead of painting those, I actually stippled those again with white, matte white and matte black, so then mask over the other, and then sort of just try to tidy up a few things. And then I even got a screwdriver, a file at the end, and actually put some scratches on it, just lightly, so it just went through to the yellow. And that's how I did the weathering on the arm. This is a bit more of the grey, and then this is supposed to be grease and grime in this section here.
Ta-da!